Hi everyone, welcome to the Masters Experience series. Thank you for being early. Well, it is Friday. How's the weekend coming? And I hope you're excited about it. Time flies. It's already our 10th session of the Masters Experience series. I hope you're enjoying all these master classes that we're bringing to you, which are recorded live and made available on HeadHunt's Facebook page. With that being said, we shall begin. Welcome to the Masters Experience series brought to you by HeadHunt in partnership with NUS Institute of System Science. My name's Tammy. Broadcasting live, we have with us Edgar, who will open the session with an introduction on ISS programs. Thereafter, our speaker for today, Mr. Tan Cher Wah, will share on the topic of building a native Android application. Now, before I hand over the time to Edgar, please note that there is a Q&A function at the bottom of your screen. Please feel free to take your questions at any time. Type in your questions at any time during the presentation. We'll also be conducting our feedback poll at the end of the session. Without further ado, I'll now pass the time to Edgar. Edgar, over to you.
Thank you very much, Tammy. Hi, everyone. Good afternoon to you. Thank you for joining us today. My name is Edgar from NUS ISS. So before we start the session, I'm just going to take about 5 to 10 minutes to run through with you the kind of programs that we have here at NUS ISS. And then I'll hand the time over to Mr. Tan Cher Wah, who will share more with you about today's topic. Okay, so for NUS ISS, we are a part of NUS. And as you know, NUS is currently the #1 university in Asia, and we're ranked 11th globally. So what's more important is that for computing and computer science and information systems, NUS is ranked 4th in the world. So the quality of education that you get here is definitely very, very high. So for NUS ISS, we are actually a continuing education institute, and we just turned 40. So we're very focused actually on practice-based education. So what that means, and you will see later, is that everything we do is meant to be applied. So whatever you learn is very much based on current job scopes that are out there. And we're also a pioneer in alternative pathway education. And I'll tell you more about that later. So this is just a glance at all our teaching staff. Cher Wah is also inside. So Mr. Tan Cher Wah is also inside as a speaker for today. So most of them do have PhDs, some of them don't, but on average, all of them will have at least 23 years of industry experience. So that means that whatever you learn with NUS ISS, you don't just hear the normal case studies, but you also hear experiences from all our lecturers. So this is what I mean by alternative pathway education. That means that other than the straight-on, graduate diplomas and master's programs, we also have various ways that allow you to stack up to a master's program or a graduate diploma. So that means that you can take on the courses in bite sizes, and it doesn't necessarily mean that you have to commit 1 to 2 years of your time directly into a master's program or graduate diploma. So the programs that we have here at NUS ISS, we have the Masters of Technology that is in Enterprise Business Analytics, so that focuses very much on data science, on intelligent systems, so that focuses more on artificial intelligence, as well as on software engineering, so that is more general in nature, a Masters of Technology in Software Engineering, but it will cover bits of cybersecurity as well as platforms. And today we also you also find out more about graduate diploma in systems analysis. And last of all, we do have a Master's of Technology in Digital Leadership, which is very much like an EMBA. So it's more for the senior execs. So just a quick run through our Masters of Technology in in Enterprise Business Analytics, in Intelligent Systems, Software Engineering. So that's the core of the master's programs that we have here. They're all 1 year full-time or 2 years part-time. And it's about 7 to 8 months of study, 4 to 5 months of internship for the full-time students. Of course, if you're doing it part-time, there will not be an internship. You'll just do a capstone project because you're already working. So the internship will be sourced by NUS, and generally for these Masters of Technology programs, you will need programming experience as well as 2 years of working experience. So other than the full-time and part-time concept or model of study, you can also take the stackable route. And what that means is this. So if you look at, this is an example of our enterprise business analytics course curriculum. You can see that there are many different modules like statistics for business, statistics boot camps. What we have done is we have grouped some of the modules together and they form what we call a graduate certificate. So you have 2 foundation graduate certificates and then you have 4 specialist certificates. So you need to, so in order to get the Masters of Technology, in order to obtain this master's degree, in enterprise business analytics, you will have to complete 2 foundation certificates, 2 specialist certificates, so 2 out of 4. And from there, you finish off the capstone project and you will be eligible to graduate with the Masters of Technology in enterprise business analytics. All right, so that's how it works. So it's possible to stack it up by taking grad certs individually or even the individual modules, or you can commit to a 1-year or 2-year full-time or part-time program. All right, so the same goes for our intelligent systems masters as well as the software engineering masters. So the last masters that I introduced to you is the digital leadership. As I mentioned, it's a 2-year part-time program. It's targeted at senior executives, and there is a stackable route that is also available. Yeah, so you don't have to commit to the entire 2 years. So today's focus, of course, is the Graduate Diploma in Systems Analysis. It's the very first program that was introduced at NUS ISS 40 years ago and is still around today. And these are just some of the people that have gone through it. You can see we have, this is the CTO of the Smart Local. He went through this program. He had a bachelor's degree in communications, all right? And then we have people from all the various backgrounds, whether it's political science or finance or even engineering. They have all gone through healthcare as well, okay? So yeah, this is Rubina. So she was a healthcare consultant. Yeah, then she took the graduate diploma in systems analysis. And we also have mid-career switchers. Okay, they switched mid-career. They decided that they prefer IT, so they switch over. So this graduate diploma really is targeted at non-IT professionals. It's really a conversion course. So it's also a postgraduate diploma. So that means that it's somewhere between a bachelor's degree and a master's degree. All right, so it's meant to target non-IT professionals. It's meant to give you entry to the world of IT. And of course, the graduate diploma is awarded by the National University of Singapore. Okay, so these are the 5 subjects or what we call graduate certificates that are in this graduate diploma. So they will cover a whole range from your foundation certificate to web development to mobile development, which is what we'll be talking about today, as well as machine learning. And then you also do some design. So you understand agile methodology. This will teach you programming languages as well, things like Python, like R. So that's what it's meant to do, is to convert you into the IT field. Not only that, you can see later on that, okay, so this is an example. This is a job description, okay? So this job description is by PayPal. And what they are looking for, you can see that every single line that they're looking for is covered in the graduate diploma. So it's really meant to fulfill a job function. That's why we say that the courses here at NUS ISS is very much practice focused. It's very much application based. So the internships, the graduate diploma is a full-time program. We have 2 intakes a year. So you either take it full-time or you take it stackable. We don't have a part-time degree for this, okay? So it's a full-time program. It comes with 5 months of internship. The internships are sourced by NUS, and you can see that they do go to very, very good companies because this is NUS. So that's why you have an opportunity to intern at companies like DBS, Shopee, Accenture, and they come with a minimum stipend of $800 a month. So in terms of English language proficiency, you will need IELTS unless you have studied in Singapore or you have graduated from any of the Singapore universities, then you do not need, that's waived. But you still need to pass an aptitude test as well as an interview. Okay, so the aptitude test is 40 multiple choice questions. It's very much based on your mathematical ability as well as your reasoning and logic. So they won't test you on things like programming because this is meant to teach you programming. So there won't be any programming questions and things like that. Okay, so last bit, the fees for the graduate diploma. Singapore citizens with MOE subsidies is about 9,500. For PRs, it's about 15,000. For international students, the full fee is about 37,100 plus. And the important dates to take note of: August 22, we're currently open for application, and we will close in April. Okay, so that's it on my end. I'm going to hand the time now over to Mr. Tan Cher Wah. He'll share more with you about today's topic. Cannot hear. Cannot hear. Sorry.
Hello, everyone. I'm Cher Wah. I'm a lecturer at NUS ISS. I teach mainly technical classes such as web development, mobile development, and machine learning. Right. So, welcome to the talk. Today we are going to look at how we build native Android apps. Right. Let me share my screen. Right. So I broke this talk into two parts. The first part, we're going to look at different approaches in building Android apps. The second part is building a more non-trivial native Android app that actually plays background music. Right. Just a caveat is that this talk will involve quite a number of live demos, and I'll be switching back and forth quite a bit. And we are going to deep dive a little bit. So we'll be seeing under the hood what how everything is hooked up and get the app working. So first part, let's look at different approaches to building Android apps. So let me paint a scenario. So my boss asked me to build a web application, right? So, but he has the intention to bring this web application into Android, right? If it gets popular. So, but he doesn't tell me that, right? So I'm assigned to build this web application. So let's say the web application is basically to bring up the company's location, right? And you can click on a button to highlight that location. Right. So in this app, I use the Google Map, and then I make it locate NUS ISS. I draw a polygon on it. I can clear a polygon from it. Right. So the key components that I use for this web application is JavaScript. So JavaScript is the language for the browser. It's what makes everything interactive in the browser. And I make use of the Google Map API. Right? And that's how I present a map on the browser. Right? So let's take a demo and then we look at the code. Right. So here's the app that I built. So I basically run it by this is my browser. So this is my browser. I had it in my local server, so it's on my machine. No one else can access it. So this is how developers usually develop their software, right? Local first, then after that we deploy to the cloud, for example. Right. So now when I run my application that's written by me, notice that it shows the map, right? NUS ISS. I can do a couple of things with it. I can drag this and show the street view, right? So this is NUS ISS a couple of months ago. It was in renovation, so now it's much looks great. I could also look at the satellite view, right? So all these are provided by the Google Map when I just launched it, right? So I didn't add any code to it, right? So now back to my map view. So all I added is this button on the left-hand corner, right? So when I click on the button, I want to highlight where NUS ISS is, right? And I could, of course, I could zoom in a bit, and then I could clear it. So this is a very simple web application, and I'm going to convert this into an Android app later, right? But for now, let's take a look at how I developed this web application, because I want to show the difference in the effort in using different approaches for Android apps, right? So the code that I use for developing that software is this. So this is all the code that is to bring up the map, right? So at the very beginning, let me just quickly show that I specified where the map should be displayed, right? So it's at this one location, and I tell the Google Map that please call me, right, when you are ready. So when it's ready, has displayed fully on the browser, right? You will call me over here, and I basically say where I want to center the map. I give it a latitude, longitude, right, and that's where it's centered. And I give it a zoom factor, right, and that's all it does, right? And then for the button, I create a overlaying button at the bottom left, right? And the button basically allows me to detect a couple of things. When it's clicked on it, I'm going to draw the polygon, all right? And when it's clicked again, I will just clear the polygon, right? And how do I draw the polygon? It is very simple. I specify 4 points, 4 longitude and latitude that surrounds NUS ISS in the map, right? And then I provide some of the attributes to say what is the color of the outline of the polygon and what's the color to shade it. And there I have it. That's the polygon, right? And when I want to clear it, I basically provide ask it to clear it, right, with nothing, right, without any points, right? So it will be removed. So that's a very simple web application, and we saw what it did. Right now, let's go back to the slides, and now I've done the web application. My boss is quite happy with it. So what it says, now, how about we move this to Android app, right? So people can consume it easily. All right. So what are the choices open to me, right? How do I do that? Well, off the cuff, right? I can think of 3 possible approaches. One is what is called web-based, right? Another one is a hybrid, and the third one is native, right? So I will go through each one of them. I will show you the code that I wrote for each one of them, right? And then we will run the demo for each one of them to see the differences, right? So let's take a look at web-based. So web-based is the first thing I would think of if it's just pure web applications. So the development effort and the time to market is much shorter, right? Because most of the things I can reuse using the web applications logic, right? But the cons for this would be I can't really access a lot of the my phone's functionalities, and performance might not be as good because I'm writing a few layers away from the actual Android system. Right. So for this web application, for this web-based Android app, I use a built-in Android component, software component that is called WebView. And this WebView allows me to render HTML page and run JavaScript code. So it is sufficient for me to just load my the HTML page that I showed just now, and then it should run. Right? The amount of code, Java code that I need to write is very little. Right? So let me do a quick demo, and then we look at the code. All right, so I just brought up the Android Studio. So perhaps I should, let me give a quick tour of the Android Studio. Right. So if you look at, on the right, you notice that there's this software that looks a lot like a mobile phone, right? So this is a emulator. So it emulates the functionality of a real world phone, right? And that's how software developers develop their mobile apps, right? Usually they will deploy it to this emulator, make sure that it works, and then finally they will deploy it to an actual physical phone for real testing, right? But this emulator can emulate a lot of functionality, so which I will show you later, right? So, right. So on the middle portion of the this integrated development environment, right, is the source code, right? This is the code, Java code that I need to write to make my application come alive, right? And on the left-hand part of this panel, the left panel, is the structure of my project, right? And then this is where I can create my user interface, right, for the user to interact with. Right? So notice that over here, I have a small little web view, right? The software component that I talked about that can render HTML page and run JavaScript, right? And I will make use of this to display the software, the map that I showed just now. Right? So let me do a quick run on it. So now I'm going to I'm deploying my code into the emulator, right? So, right. So it's loading up. All right, so notice that it looks pretty much the same as the web application because it's just loading up a HTML page into the web view. And again, I can do all the things that I did for when I was in the browser. I can click on this, bring it, hold on, let me, there I'm looking at the street view, right? And I can also look at the satellite, like what I did earlier on, okay? So now let me go back. All right, so now let's see if the functionality still works, right? So first of all, it does bring NUS ISS, the map in the middle of the screen. That's good. All right. Now there's a button, right, that says draw. Right. Let's click on this, and right, there's a polygon that is drawn. Right. I can clear this polygon just like earlier on. So you notice that I almost didn't do much, right? So what is the code that actually drives this app? Let's look at this. This is all the code that drives this, right? And why this is it? This part is basically to say that I want to load a web view, and the content that I want to have it load is basically the HTML file that I created that I shown just now. All right. Now, so this is the simplest way, right, to create an Android app, right? All right. So, so now let's take a look at another approach. Right, so I will. There's another approach, which is the hybrid approach, right? So this approach is quite fast to develop, and its go-to-market time is short, and it allows us to have access to the native device functionalities, right? Which I will show later, right? But of course, the performance is not as would not be as good as when we are writing to the Matter for the Android system, right? Now let's take a look. What are the components that I use to develop this Android app, right? Again, I use the web view, right? This is the part of the hybrid. I'm using the existing part of it, and I'm using one more thing, which is the phone's accelerometer. So this is the sensor of the phone, right? So I'm going to add one functionality to it, right? Instead of clearing by clicking on the button, I'm going to clear the polygon by shaking the phone, right? So when the phone shakes, right, I will clear the polygon. Okay. Now the Java code that I need is more, right, than the previous web-based version, right? Let's take a quick demo, and then we'll look at the code. So let me load up the hybrid version. All right, so right, you can see that there are a bit more code here, right? And the UI, let's quickly look at UI. The UI is still the same. It's the web view, right? So nothing has changed here. Perhaps let me run this app first, right? Just to do a quick demo, right? Then we look at the code. So this is the hybrid version. Okay, so it's loading. Oh, so we can see that it looks still exactly the same, right? Because we are using the web view. So that part, nothing has changed yet. All right. So now, if I click on draw, right, all the functionality remains. Okay. But now I'm going to use the phone sensor, right, to detect the shake. Right. So here we go. So these are more controls for the emulator. So what I want is the sensor, right? So it will emulate sensors, right? So you notice that over here, this is the phone. The phone is in a vertical position. So I'm going to shake this phone by moving this left and right. All right. So notice this part. What happens when I shake left and right? Okay, I'm going to left and right. Okay, all right. So you notice that it detected that the phone has shake, and it erased the polygon. All right. So you notice that I have make use of the phone physical ability, right? Okay. So now let's quickly look at the code, right, and see what changes did we make that allows me to do that, right? So the first part of the code looks the same. This web view here, right, which is the one that renders the HTML, right? So this has not changed, right? The only thing that has changed is that I request a sensor, right, the accelerometer sensor from the Android system, right? Basically, it tells it that I'm going to listen to this sensor. Please send me the data, all right? So what it did is it will, at a certain periodic interval, it will keep sending me data for that sensor. All right. So now this is the part that I will receive the sensor data, right? So I need to do a bit of trick here because I need to know how do I determine whether the phone has moved to the left and to the right, right? So basically what I did here is that I checked what's the last value that is given to me and what is the current value that is given to me, all right? And if both the values, one of value is positive, the other one is negative, then that means they are in opposite direction. So it's more of like a shake, right? And how do I, in computing, how do I actually interpret that as code to tell the system, right? So basically I say, take one value, right? And take another value, right? These two values, I times them together, right? If both of them are positive, right, I'm going to get a positive number, right? If both of them are negative, I will get a positive number, right? So that's not what I want, right? What I want is I want a positive number times a negative number, and then it will give me a negative value, which is this line here, which says smaller than 0, which is the negative value, right? So once I have that, I know that at least, right, it has been shaken once, right? So I wait for it to shake twice to make as confirmation that the user really wants to erase the polygon, all right? And then once it did an erase, again, this is the hybrid part of it, I call into the web application, right? The web view that has the JavaScript code to say, please clear the polygon, right? And then refresh the button to say draw instead of clear because I've already cleared the polygon. Right. So you notice that not too much code, still reasonable. All right, and this is the hybrid way of doing things, sort of the best of both worlds. All right. So now let's take a look at the third alternative. So the third alternative would be the native Android app. Right. So this is go full Java, right? And the pros here would be I can access every single function on the device. The performance will be great, right? But not so great would be the development effort. It takes longer and the time to market will be longer as well. Right? So the key components that I use to build the next app is actually a map view software component. This component is provided by Google. It comes prepackaged, right? The only difference that from a web view is that this map view can only display a Google map, right? And it doesn't understand JavaScript, etc. All right, but it's native to the Android development. And again, I'm going to use the accelerometer sensor to detect the shake, right? And in terms of Java code, there is quite a bit more, right? So let me do a quick demo and then we look at the code. So, all right. So I have the project loaded. I'm going to run the app now. Okay, so this is a full Java mode, right? It's full Android mode. So you notice that I can still bring the map to the middle, right? So this is still NUS ISS, and I can still do a draw polygon on it. I can clear polygon as well. But let's do the same thing as the shaker, right? Let's shake this app. All right, and then you can see that the polygon is erased. All right, so let's take a quick look at the code, right? So what is the same? What is different? So if now we look at the UI, right, that I have to create, you notice that now I have to use a map view instead of a web view. So the web view is no longer in my user interface, right? And then I have to add a button, a native button myself, right, which is this particular button, right? So I have to control all this, right, in my Java code. Now, in my code, so what has changed, right? So I now have to handle the map view, right, to initialize it properly so that it will work. I have to handle the button, the draw clear button, and the only thing that hasn't changed is the sensor. The sensor, I'm still using the same code, right? So when the map view starts, it will ask me for where to place the map, right? So I'll say, okay, latitude, longitude, like this. So that's why it's placed in the middle, and that's where NUS ISS, right? And then I say I want to zoom at a certain level, right? So again, I have to control this using the Java code, right? And now when I draw the polygon, I can no longer use the JavaScript code that I've earlier written. I have to follow the specs, right? That is by the Google that says how do I draw a polygon or for its map view, all right? So the rest of that, and then I have to handle the button refresh myself, right? So it's still manageable, but it seems to be a lot more code now, right, than earlier, right? So these are the three different approaches, right, that you could use. So usually when I want speed, I will really go for the native, right? If I want a very fast development, right, go to the market very early, then I will do the web-based version. Right. Hybrid is usually a very promising option as well, right? Because it gives you the best of both worlds, right? Right. So with that, I end the first part of the talk, right? So now I'm going to the second part whereby we're going to look at how we build a native Android app to actually do more complex things, right? And in this part two, I'm going to say, how do you play a background music using the Android SDK, right? So the application looks like the one on the left, right? It displays a list of songs that I can pick from, right? And when I click on it, I can play background music. I can move away from this application. The music will keep playing, right? So it will, and then I can go back to it again, right? Later I'll show you how. And then you can select a song again, a different song to play in the background, right? And it will also notify me what's the song that is currently playing, because I program it such that when it's done with this song, it will go to the next song, right? So every time it changes the song, it will notify me in the status bar what is the song title. Okay, and of course I can start and stop the application. All right, so let me do a quick demonstration of this application. Right. Right, so this is the application. It loads up as a list of songs, right, which I can click to play. But we can't really share the song. We have some little bit of technical difficulties, right? But trust me, it works, right? So when I click on it, it will play, and I can. So if I'm let me click on it and it's playing, right? I can move away from it, right? I move away from it. It's still playing, right? And it will tell me what is the song that is currently playing. You notice that I pull down from the status bar, and it says the song right now is called Sunny that I'm playing, right? Now, the song is playing in the background. I can do anything I want, okay? I can surf the web, right, while listening to the background music, for example. I have the website apple.com.sg. Can do some shopping, right, while listening to song, right? So and when I want to, let's say, stop it or to go back to it, all I need to do is drag the status bar again, locate the notification, click on it, right? When I click on it, it will bring the app back to the front, right? And this is where I can either stop it or choose a new song, right? So this is the app, and let's take a quick look at all the components, right, that is needed to build such an app. Right. Right. So these are the few key components, right, to build the app. So I'll go through them quickly, right? The first part is I need the user interfaces. So you see the list of songs, etc., right? So I need to create that, right? And then an activity. So in Android, right, there's this concept of an activity. An activity is anything that has a screen that the user can interact with. So they call that activity, right? And it runs in the foreground. And that's why whenever we need to bring the song back, right, list of song back, we have to get the activity back, right? That's how we can control the song list, right? Then there's another key component in Android, which is Android services, right? So Android service is this concept. It is the code that runs in the background. It doesn't need any UI, right? And this is the component that is playing our song while we are doing browsing away from the application, right? And I need to utilize the notification manager in the Android system as well, right? This is the component that I use to tell the user that every time I changes a song, right, show this song name to the user, all right? And I need the media engine from Android, right? This is the one that actually plays the MP3 songs, right? And I need to get my MP3 songs as well. I would like to shout out to bandsong.com, right? This is where I get all the songs. And I actually write to them to say, if can I use them for this talk, and they gracefully says yes. So please check them out, right? Okay, so now let's do a deep dive, right, into the code to see how this is built. Right. Right. So first off, I need to bring all my MP3 files that I downloaded into a folder. So you notice on the left-hand side, these are all my MP3 files, right, which I'll call in my code to play, right? These are the user interface that I use to display the songs list, right? And I'm just going to touch on two key components here, which is the activity and the service, right? Let me look at the activity first. So the activity is pretty simple, right? So this is the one over here that shows the user interface to the user and interact with the user to say, oh, select another song, etc. Right? And at the very beginning, I need to tell the system how many songs I want to play. So I'm managing the song list with the code, right? So I say, oh, these are all the music that I want to play, right? And each of these maps is going to map to one of the MP3 files in my folder. Okay. And I'm going to have a way to initialize my Android service, right? So this is the part that I say that, well, this is the list of songs, right? Use this to play, right? So we want to have the service as generic as possible, right? So that other applications that I write can also use this music service. I don't want to put all the list of songs, right, in that service, right? Or if not, you only know how to play this service. I want it to play any songs, right, that the activity tells it to play, right? And then notice that there's this on item click. So which means that when the activity detects that the user has clicked on any of the song, it is going to send a message to the service, right? To say that, all right, now you should play this song, right? And that's how they work together, right? And the music service, this is the music service. So this is the place where it receives the command, right? So it's very simple design. You only knows 3 commands. One is to play a song, right? And if you want to play a song, which song is it, right? And the second command it knows is I want to stop playing, right? And the third one is to initialize the song so that it knows what are the songs that are available, right? And then you have some logic to play the song, and this play song will go to that folder. You notice that there's a raw here. So it knows how to go to that folder and then get the music and play it, right? And then it knows how to stop. So it will call the player, which is the media player, right, to stop playing, right, when it's done. And notice that there's a notification manager as well to show what is the song title that is playing, right? This is the code that I create, right, to write to that status bar via this notification manager, right? Right. So there we have it. That's the main components that created this app, right? So with that, I would like to end my talk. I would like to thank you for your attention. Oh, so right. So there's a question that is about what resources are there to pick up iOS and Android app programming. We have one course in GradDip. It's mainly just to do Android development, and there are quite a lot of workshops and resources out there, like Android tutorials, iOS tutorials that basically provide step-by-step instructions in how to construct an app, right? But the only difference is that when it comes to NUS IIS, what we did is we not only provide the instructions, right? The lecturers are there, right, to curate the information that is provided to students, and we are there to also help the students to resolve some of the issues or some of the doubts that they have when creating the apps.
Joel, I think there are a few other questions for you.
Okay. Kawai from DSO, hi. You mentioned the separate Android workshops just for DSO colleagues, I guess. We do have that kind of arrangements, and we will, so all your colleagues will be in one class and no one else, Right? We do have that arrangement at ISS, NUS ISS. So Terence has a question about whether the native song player can be done as a web app. That could be a bit more challenging because what we did is we use a lot of components that is provided by the Android systems to do the playing. Right? You could replicate the same thing, but slightly differently in a fully JavaScript manner. I'm sure that can be done. But if you want to do a fully web application and then bring it into the Android environment, that will need a bit more tweaking. Okay. So Alan has a question about some network properties of the Android system. In the emulator, right? You could emulate network as well, right? If you're talking about changing the network address, calling different machines, you could do that in the code itself, right? But the emulator allows us to do other things. Like for example, let me do a quick show here. So I go to the network part of it, right? I could emulate whether the network is poor, right? Whether it's strong, right? So you can test your app, right? How does it react under different network signals, all right? So you can also do like, what happens if your battery is not fully charged? What happens then when it is almost like 0%, right? All this, right, you can emulate with that emulator. All right, so Terence is talking about React.js. So React.js, from what I understand, is basically generating HTML user interfaces, and it uses JavaScript as well. So in that kind of situation, in theory, right, a web application that's built using React.js should be able to go into the web view of a Android app and should run fine. Right? All right.
Thank you, Cher Wah and Edgar, for your time today and for this very interesting session on building a native app. We hope you've enjoyed today's session, and we'll now invite you to participate in our feedback poll. Please give us your honest feedback so that we can further improve on our Master's Experience series. The feedback poll should be popping up on your screen, so please take a few moments to share with us your observations. Just a couple more seconds to go. Thank you very much for your feedback and for joining us today. This masterclass is brought to you by HeadHunt in partnership with NUS ISS. We welcome you to join us next Tuesday, 22nd of February, on the topic of the future of leading, presented by Kaplan Higher Education Institute. Do sign up early on our website, postgrad.sg. With that, we will wrap up today's session. Thank you, and we see you next week. Bye.